In question 10, a curve has equation y equals to f of x, and it is given that f dash or the derivative of f of x is 3x to the power half minus 2x to the power minus half. The point A is the only point on the curve at which the gradient is minus 1. In part 1, we have to find the x coordinate of A. Now we know that the gradient is minus 1, or we can say that that f dash of x is equals to minus 1. So we can write the expression of f dash of x, which is 3x to the power half minus 2 upon x to the power half equals to minus 1. Taking the LCM, so the LCM will be x to the power 1 upon 2. X to the power half multiplied by x to the power half, that will become 3x minus 2 equals to minus 1. Cross multiplying, we'll get 3x minus 2 is equals to negative x to the power half. Now to solve this equation, we can whole square both the sides, or we can use a substitution in place of x. So if you whole square both the sides, so we'll get this as 9x squared minus, so this will be 2 times 2, 4 times 3, which is 12x. So this will become minus 12x plus 4 is equals to, so minus x half 1 upon 2 to the power whole square will become a plus x. Taking this x on the left hand side, that will become 9x squared minus 13x plus 4 equals to 0. Now factorizing using middle term breaking, we'll get 9x squared minus 9x minus 4x plus 4 equals to 0. Taking 9x common, this will be x minus 1. Taking 4 common, that will be x minus 1 equals to 0. Simplifying, we'll get 9x minus 4 and x minus 1 equals to 0. So x will be equals to 1 and x will be equals to 4 upon 9. Now, as if we take x equals to 1 up here, so this will become 3 minus 2 upon 1, which will not be equals to minus 1, as 3 minus 2 is a positive 1. It means that the only value of x that we can take will be 4 upon 9. So the x coordinate of A will be 4 upon 9. In part 2, it says given that the curve also passes through the point 4, 10, we have to find the y coordinate of A, giving our answer as a fraction. Now to find the y coordinate of A, we first need to find the equation of the function f of x. So we know that the derivative f dash of x is given by, so f dash of x is equals to 3x to the power half minus 2x to the power minus 1 upon 2. So taking the integral on both the sides, so taking the integral of f dash of x, that will be f of x is equals to, so the power will increase by 1. So 1 upon 2 plus 1 is 3 upon 2. And we'll divide by the new power, which is 3 upon 2, minus increasing the power by 1, that will become 1 upon 2. And this will also divide by 1 upon 2. And we'll add a constant over here. Simplifying this, we can write this as f of x will be equals to, so 3 and 3 will cancel. The 2 will go in the numerator. So that will become 2x to the power 3 upon 2 minus 4x to the power 1 upon 2 plus c. Now to find the value of c, it says that the curve passes through the points 4, 10. Now as the curve passes through the points 4, 10, we can write 10 in place of f of x, and this will be 2 into 2 to the power 3 upon 2 minus 4 into 2 to the power 1 upon 2 plus c. So this will be 10 is equals to 2 into, so this is x equals to 4. So we'll have to substitute x equals to 4 up here. So this will be 4 to the power 3 upon 2. So square root of 4 is 2 and 2 cube is 8 minus the square root of 4 is 2. So that will be 4 into 2 plus c. So c will be equals to 10 is equals to 16 minus 8 plus c. So 16 minus 8 is 8 and 10 minus 8 will be equals to c. So the value of c will be equals to 2. Now, once we have the value of c, we can write first the function as f of x will be equals to 2x to the power 3 upon 2 minus 4x to the power 1 upon 2 plus 2. And now to find the y coordinate of A, we'll substitute the x coordinate, which we found in the previous part, which was 4 upon 9. So substituting x as 4 upon 9. So this will be 2 into 4 upon 9 to the power 3 upon 2 minus 4 into 4 upon 9 to the power 1 upon 2 plus 2. We can substitute this completely in the calculator to get the y value or the value of the function when x is 4 upon 9, or the square root of 4 is 2 and 2 cube is 8. The square root of 9 is 3 and 3 cube is 27. Minus 4 into the square root of 4 is 2. The square root of 9 is 3 plus 2. So this will become 16 upon 27 minus, so this will be 2 upon 3 minus 8 upon 3 plus 2. Taking the LCM and simplifying, this will become 16 minus, so this will multiply by 9 and this will also multiply by 9. So this will be 16 minus 72. And this is, the denominator is 1, so this will multiply by 27. So this will be plus 54 upon 27. So 16 plus 54 is 70. 70 minus 2 is minus 2. So the value of the function of f of x, or the value of y, will be minus 2 upon 27. So we can say that the y coordinate for A will be minus 2 upon 27.